Dear students, now we are going to discuss another important case tools, object oriented analysis and design and unified modeling language. What is OOAD? That means object oriented analysis and design. Object-oriented analysis and design is a software engineering approach that models a system as a group of interacting objects. Each object represents some entity of interest in the system being modeled and is characterized by its class, its state, and its behavior. Various models can be created to show the static structure, dynamic behavior, and runtime deployment of these collaborating objects. There are a number of different notations for representing these models, such as the Unified Modeling Language. Object-oriented analysis applies object modeling techniques to analyze the functional requirements for a system. Object-oriented design elaborates the analysis models to produce implementation specifications. Object-oriented analysis focuses on what the system does, whereas object-oriented design focuses on how the system does it. Let us discuss what is object-oriented systems. An object-oriented system is composed of objects. The behavior of the system results from the collaboration of those objects. Collaboration between objects involves them sending messages to each other. Sending a message differs from calling a function in that when a target object receives the message, it itself decides what function to carry out to service that message. The same message may be implemented by many different functions. The one selected depending on the state of the target object. The implementation of message sending varies depending on the architecture of the system being modeled and the location of the objects being communicated with. Object-oriented analysis. Object-oriented analysis looks at the problem domain with the aim of producing a conceptual model of the information that exists in the area being analyzed. Analysis models do not consider any implementation constraints that might exist, such as concurrency, distribution, persistence, or how the system is to be built. Implementation constraints are dealt during object-oriented design. Analysis is done before the design. The sources for the analysis can be written requirement statement, a formal vision document, interviews with stakeholders or other interested parties. A system may be divided into multiple domains representing different business, technological, or other areas of interest, each of which are analyzed separately. The result of object-oriented analysis is a description of what the system is functionally required to do in the form of a conceptual model that will typically be presented as a set of use cases, one or more UML class diagrams, and a number of interaction diagrams. It may also include some kind of user interface markup. The purpose of object-oriented analysis is to develop a model that describes a computer software as it works to satisfy a set of customer-defined requirements. Object-oriented design. Object-oriented design transforms the conceptual model produced in object-oriented analysis to take account of the constraints imposed by the chosen architecture and any non-functional technological or environmental constraints such as transaction throughput, response time, runtime platform, development environment, or programming language. The concepts in the analysis model are mapped onto implementation classes and interfaces. The result is a model of the solution domain, a detailed description of how the system is to be built. The next concept is Unified Modeling Language, that is UML. Unified Modeling Language is the set of notations, models, and diagrams used when developing object-oriented systems. UML is the industry standard object-oriented visual modeling language. UML allows the analyst ways of describing structure, behavior of significant parts of system and their relationship. UML is a standardized general purpose modeling language in the field of software engineering. The standard is managed and was created by the Object Management Group. UML includes a set of graphic notation techniques to create visual models of software-intensive systems. The Unified Modeling Language is commonly used to visualize and construct systems which are software-intensive. Because software has become much more complex in recent years, developers are finding it more challenging to build complex applications within short time periods. Even when they do, these software applications are often filled with bugs, and it can take programmers weeks to find and fix them. This time that has been wasted, since an approach could have been used which would have reduced the number of bugs before the application was completed. However, it should be emphasized that UML is not limited simply modeling software. It can also be used to build models for system engineering, business processes, and organization structures. The Unified Modeling Language is important for a number of reasons. First, it has been used as a catalyst for advancement of technologies which are model-driven, and some of these include model-driven development and model-driven architecture. Because an emphasis has been placed on the importance of graphic notation, UML is proficient in meeting this demand, and it can be used to represent behaviors, classes, and aggregation. While software developers were forced to deal with more rudimentary issues in the past, languages like UML have now allowed them to focus on the structure and design of their software programs. It should also be noted that UML models can be transformed into various other representations, often without a great deal of effort. There are different types of UML diagrams are used for various purposes. such as case diagram, use case diagram, class diagram, sequence diagram, collaboration diagram, and state diagram. I have given an example of use case diagram for the clinical purpose. Okay students, I hope you understood the concept of object oriented analysis and design and what is unified modeling language. So with this we have completed the discussion on case tools. We will have a discussion on the other topics in third unit in the next video. Thank you.